But this data must have some encryption protection. For these data, encrypt on match, and then sent to the peer. So this is a different application scenario. That's normal. The traffic coming from this network segment will go online normally. Also take the internet, but without encrypting its data, because it's not confidential data. This is the application scenario of the ACL we mentioned. Let's talk about the classification of ACL next. In fact, you can understand ACL as a tool. It is a very flexible tool. Match various data in the network. ACL, according to different matching conditions, can be divided into two categories. One is called the basic ACL. One is called advanced ACL. The basic ACL can only be matched against the source IP of the data. That is, it can only get the source IP. It's imprecise. In fact, it has a wider range. So we sometimes feel it is a bit inappropriate to use basic ACL, because the entire range it matches is actually larger, not refined. For advanced ACLs, it can match these. This thing is called a quintuple. The 5-tuple refers to source IP and destination IP in layer 3, plus the protocol in the 3 layers, plus the source port and destination port in the 4th layer. We call it a quintuple. That is, in a stream of data, there are some parameters that are the same. We don't have a particularly detailed understanding of TCP in our Cisco courses. Advanced ACLs can be matched based on 5 tuples. That is to say, I can now pass the form of source IP and destination IP plus protocol, even the form where all the parameters are connected together, to match the previous data. It is more precise. So here are some differences between them. So how do you know whether an ACL is a basic ACL or an advanced ACL? When we define ACL, there will be a number on the back. If the number is between 1 and 99, then you can only configure the source IP. If it is between 100 and 199, there are more parameters that can be configured later. Define the basic ACL and advanced ACL based on the number written behind the ACL. Then define the range of parameters that can be matched inside. In fact, we don't have many matching parameters for ACL, besides being a list. In fact, there is another thing called rules. So we just want to define. For example, ACL, we write a number. It's like a list. You can think of it as a catch list. In this list there will be different rules. It's like the cops can make a catch plan. That's in the plan. Many people can be arrested. Many cases may be parallel. Assume that prisoner A is caught, sentenced to 3 years in combination with its case. Prisoner B sentenced to 4 years. Prisoner C sentenced to 6 years. Other inmates detained. Each arrest plan does not only arrest one person. Same. The ACL list is equivalent to a plan. It is not only for one data or a string of data to perform actions. It can also match multiple data at the same time, and then perform different actions. This can all be achieved in a list. We call this a rule. That is, different rules catch different data, have different actions on it. Multiple rules can be defined in an ACL list. Containment, according to different rules, can take different actions. So ACL is like a filter. Different filters can be used for different data. It's just a function in the device. We can't talk about configuration today. Let's start with some basic questions. There is only one relatively difficult knowledge point in ACL. It is to perform the hook under the interface. Many friends will forget this configuration until the end. For example, this is a router. For routers, Surely there are lines on both sides. Assuming it's not currently enforcing any ACLs. Do not do any ACL-related functions. It is normal data forwarding. A data will be from here into this device. If there are no restrictions, by default, Layer 3 will forward according to the routing table. 1 to 99 is enough. Because later data comes in. May also search to make the corresponding match. Generally speaking, there may be only a dozen or 20. Too many words are actually unnecessary. Okay. Layer 3 is actually a routing table. That is to say, if now the data comes in, it does not impose any restrictions on the ACL. It directly looks up the table and forwards. Since it wants to control certain data. At least do it. Either don't let this data in. Either don't let this data go out. If there is no restriction, the data will come in. When the data comes in, check its routing table. Check the table and go out. Then it can't hold the data. So all it can do is, or don't let it in, or don't let it out. Gotta have a control over it in one place. So how to control the data on the router? Data coming in and going out is actually for the interface. Router interfaces are directional. I've been emphasizing this over and over again. The interface of the device is directional. It has both receive and transmit directions. For ACL, it is a function. If an interface receives data, then this interface is an entry point for data. If an interface wants to send data, then this interface is an exit for data transmission. Therefore, the interface has an inbound and outbound direction at the same time. But for data, if data is sent from left to right, in fact, the interface on the left is the entrance for it. The interface on the right is an exit for it. The access list hangs under this interface. Please pay attention to my wording. It is hanging on. That is, since you want to control the data through it, then you have to make this control method on the interface. You need to check according to the data flow of ingress or egress. If it matches, then kill it. Where to put it depends on your configuration. But more often, most of our configuration is still at the entrance. Including the recommendations on various textbooks, are also configured at the entrance. When you learn IE in the future, you will find that it is useless to hang some strategies on the exit. Less involved in Cisco. So we often do more configuration at the entrance. For equipment, if you want to make the ACL take effect in the future, you must mount it under the interface. Hooking can also be called calling. The idea of configuring the entire ACL is actually very simple. Assume 3 steps. First, define the parameters for ACL matching. Second, after matching the parameters, you also have to define its matching action. Third, you hook this ACL to a certain direction on a certain interface. Because the interface has an inbound and outbound direction. Therefore, the outbound direction and the inbound direction have to be mounted again. Otherwise, you can't make it reachable. Before we do ACL, make sure the network is reachable. If the network is unreachable, then you do ACL is meaningless. That is, the network must be able to communicate first.